Okay, in the previous video, we learned how to multiply a row matrix by a column matrix. And if you recall, we multiply the first element times the first element, then we multiply the two second elements, and then we multiply the two third elements together and add them up. And we got a single number. Okay, here we had 5 times negative 3. We had 10 times 7. We added them up and got 55. We need to continue to do that as we expand to multiplying matrices that are not a row matrix times a column matrix. Let's learn how to multiply matrices. Given matrices A and B, and notice that I didn't put numbers in, we just put variables in, A, B, C, and D, and E, F, G, and H. The product matrix A times B is obtained as follows. So AB would be obviously just this matrix times this matrix. And here's how we get it. I'm going to make the matrix itself bigger, even though it's going to be the same size as this one. It's going to have 4 elements, 2 rows and 2 columns, just like both of these two matrices. Well, the first element, this will be the row 1, column 1. This will be row 1, column 2. This will be row 2, so row 2, column 1, and row 2, column 2. How do we get the row 1, column 1 element? Well, we simply take row 1 of the first matrix and multiply it by column 1 of the second matrix. So this is like multiplying a row matrix times a column matrix. Notice they both have 2 elements, so it'll work out correctly. And we multiply the first 2 to get AE. We multiply the second 2 to get BG, and we add them together. AE plus BG. That's the first element. That's the row, whatever we get from computing this expression, simplifying it, we would get that is the row 1, column 1 element. All right, then the second one, what's this? This is row 1, column 2. So we still take row 1, but now we're multiplying by column 2. And we get AF plus BH. All right, so that's the first row. We've got this one element, and this is the second element in the first row. Now we're going to go down to the bottom row. Well, you might guess exactly what we're going to do. This is row 2, column 1, column 2. So this time we're going to take row 2 of the first matrix and multiply it by column 1 and column 2 of the second matrix to get these 2 elements. So CE, DG, and add that together. CE plus DG. And then row 2, column 2, it'll be this times this. So CF and DH, and add them together. CF plus DH. And that's it. Now it might not be perfectly clear that this is a 2 by 2 matrix only because we have these kind of 4 expressions, but maybe I'll put just to put a little divider in between to separate the 4. This is the first element, and again, these will be numbers, and you'll be multiplying and adding them. It'd be a number, here'd be a number, another number, and another number. So that's how we multiply a 2 by 2 matrix. All right, let's take a look at an example. If A is equal to this, and B, capital B, is equal to this, find the product matrices AB and BA. So I'm going to start way over to the left. AB is equal to, and I'm going to rewrite them, 1, negative 3, 5, 4, times B, which is 2, 0, negative 4, 1. Well, as we know, when we multiply a 2 by 2 matrix from above, we're going to get another 2 by 2 matrix. So it'll be the same size. Okay, so we're going to take row 1 and column 1. So I'm going to have 1 times 2, that's 2, negative 3 times negative 4, that's 12. And add those two numbers together, 2 and 12. for 14. So you have to do a lot of adding and subtracting just to get one element when you're multiplying matrices. Let's look at this element, row 1, column 2. So row 1 of the first, column 2 of the second. 0 plus -3. That's -3. Now we're going down to the second row. So I'm going to take the second row of the first matrix and multiply by this column. And then I'll take the second row and multiply by that column to get the last two numbers. 5 times 2 is a 10. 4 times -4 is -16. Add those together and you get -6. Row 2 times column 2 will give us this, the row 2, column 2 value here in the product matrix. So 5 times 0 is 0, 4 times 1 is 4. All right, simple as that. That's the matrix AB. Now let's do BA, which would be 2, 0, -4, 1. And 1, -3, 5, 4. So all I did is switch the order of these, and let's do the multiplication. First row, first row 1 of the first matrix, column 1 of the second gives us 2 plus 0, which is 2. Then we get -6 plus 0, which is -6, for the second element in row 1. And then we're going to go row 2 times column 1 to get this element. -4 and a 5 is a 1. And then to get this one, we go row 2 times column 2, and we'll get a positive 12 plus 4 for 16. Okay, that was good practice. And one of the things that we're pointing out here is that when you're multiplying two 2-by-2 matrices like this, does the order matter? Absolutely it does. When you multiply AB, A on the left, you get this matrix. When you multiply BA, B being on the left this time, you get a completely different matrix. So I'm just going to write down a fact here. Matrix multiplication is not commutative. Now, multiplying numbers is commutative. You know, 2 times 10 equals 10 times 2. That works for any two real numbers. It doesn't matter the order that you multiply them. Matrices, it absolutely matters. Okay, and let's take a look at this one, this next example. Perform this multiplication. Well, let's start by saying, I don't know how big it's going to be, row 1 times of the first one times column 1 of the second. Can we even do that? No, we can't. We cannot take this, what we sometimes call the dot product. There has to be the same number here, a number of numbers, as here. You could take the first times a first, a second times a second, but then you still have a third down here with no third up here. So, notice in the instructions it said if possible. So how about if I just write impossible? We have size requirements, and these two matrices do not meet those requirements in order to be multiplied. And here's how we determine it. Well, note, before we do this, we have a 2-by-2, right? That's a 2-by-2, and what's this? The dimensions or size of this. 1, 2, 3 by 2 columns. 3 by 2. So these two matrices, the matrices of this size, cannot be multiplied like this. All right, now let's say that matrix A is M by N. Could be 2 by 2. And B is different size. It's R by P. Could be 3 by 2. Then AB, this product matrix, exists if and only if, what? How could we say that the number of numbers here is the same as the number of numbers here? Well, this is the number of columns. 2 columns, right? There has to be 2, and there's 3 rows here. So we want to say if the number of columns of the first one, which would be n, equals the number of rows of the second one. So the number of rows of the second one would be r. Okay, another way to look at this, and it's easier to memorize this, is that the 2 numbers I'm circling, I got some words in between them, those 2 numbers, the inside numbers, have to be equal to each other. N and R have to be equal. Is it equal here? Absolutely not. We have a 2 and a 3 on the inside. They're not equal. You can't multiply them. So in other words, what was n? N was the number of columns of A. So that is the number of columns, I put C-O-L-S, columns of A must equal the number of rows of B. It's easiest for me just to write down the dimensions or the size of each matrix and verify that the 2 inside numbers match. If they do, if they're equal, you can multiply them. If not, you can't. In addition, if A is m by n, and this time I forced it to be correct, forced them to be the same. Notice that the 2 inside numbers, m by n by p, the inside ones are equal. I guarantee I can multiply these 2 matrices together. A is this size, B is this size. Then, after you multiply them together, the resulting product matrix has size this by that. The other 2 numbers, the outside numbers, m by p in this case. Okay? All right, let's do, to finish up this video, we'll do one more example. And let's first determine if we can even do this. This is a 2 by 2 matrix on the left. And what is this one? 2 rows, 3 columns, 2 by 3. Can we multiply them? Absolutely. Those 2 numbers are the same. And what's the resulting matrix going to be? What's the size or dimension of it? 2 by 3, which means it'll look just like this, the size of this one. Okay, so row 1, let's multiply that by column 1, column 2, column 3, and that'll give us the 1, 2, 3, the 3 elements of row 1. So 0 and 2, right? 0 times 1, 1 times 2. That's a 2. 0 and a negative 1. Oops. Row 1, column 3 will be 0, 1 times negative 1, 3 will be 0 times 3. 0 plus 3, excuse me. All right, now we're down on row 2, so we're going to take this row and multiply it by column 1, column 2, column 3. 2 plus 6, 8. 0 plus negative 3, negative 3. Negative 2 plus 3 times 3 is 9. Negative 2, 9, add them together, and we get a 7. So this is the product matrix. This matrix times this matrix, 2 by 2 times 2 by 3 gives us a 2 by 3 matrix.